Welcome back. So still on matrices and determinants. So a quick reminder, please, whenever you're watching any of our video, always do well to look below the video. If you find a playlist there, make sure you always click on the playlist. It will take you to list of videos we've done on matrices and determinants. On that particular topic, it will take you to list of videos we've done. So it is very, very going to be helpful to you when you watch it from the beginning, from part 1, part 2, part 3, part 4. Do you understand? So please, whenever you're watching any of our video, look below the video. If you find a playlist there, make sure you click on the playlist. It will take you to the list of videos we've done on that particular topic. Now, here we want to explain what is minor, how you get minor of a matrix, how you get cofactor of a matrix, how you get the transpose of a matrix, and how you get the adjoint, and how you get inverse of a matrix. So if that is your issue on matrices and determinants, please stay behind and let's solve these things together. Now, let's start with 2 by 2 matrix first. Everything we'll be doing here is on 2 by 2 matrix before we move to 3 by 3 matrix. Now, let's start with minor of a 2 by 2 matrix. How do you get minor of a 2 by 2 matrix? It's very, very simple. Now, let's say we are given, for example, let's say we are given a matrix A as A, B, C, D. Now, for example, let's say we are given a matrix A and you are told to look for the minor. How do you get the minor? Now, this is the matrix we are given. To get the minor is very simple. You just say, let my A minor, let me represent my A minor with something else. Do you get? So let A minor be equals to, let me represent my A minor with something else. So let me just use, okay, let me use M1, M2, M3, M4. You know, this is a 2 by 2 matrix, 2 rows, 2 columns. This is a 2 by 2 matrix. So let me represent my A minor to be what? M1, M2, M3, M4. Now, how do you go about it? This is very simple. Now, let's pick for the first one, M1. This is how you'll be doing it though. M1. You now rewrite everything. What your matrix is, the matrix they give in your question, you write everything. I have A, B, C, D, right? Now, this M1 I'm picking first is on which position? Is on the first row, first column, right? You know, this is the first row, first column. This is the first row, second column. Second row, first column. Second row, second column, right? Don't forget, you name it row before column. Now, this is first row, first column, first row, second column, second row, first column, second row, second column. Now, this M1, what is it representing in that your matrix, in that your question? It's representing this A, right? Cancel to the row, cancel to the column. What else are you seeing? You are seeing, you are left with what? D. Do you get it? Now, we go again. Let's go for M2. M2. Now, going for M2, you write the question again. A, B, C, D. Now, the M2 is representing what in this place? Is representing this B, right? Cancel to the row, cancel to the column. What else are we seeing? C. Now, let's go for M3. You know, I'm representing my A minor to be this. I've done M1, M2. Now, let's go for M3. So, we have A, B, C, D. M3 is representing what? Is representing C, right? Is representing this C. Cancel to the row, cancel to the column. What else are we left with? B. Now, for the last one, which is M4, we have A, B, C, D. Now, M4 is what? Is representing what? D, right? Cancel to the row, cancel to column. What else are we seeing? A. So what do you want to do? We will now come back and say, what will be our A minor? Our A minor is now equals to, what's our M1? What's the answer we got for M1? D. What's the answer we got for M2? C. What's the answer we got for M3? B. The answer we got for M4? A. So this is how you get the minor of that matrix. So you see, this is how you get minor of a 2 by 2 matrix. And it is very, minor of a 2 by 2 matrix is very, very simple, because whenever you are given a 2 by 2 matrix and you are told to look for the minor, it's very, very, what do? You just interchange. This is what they do there. Take this up, bring this one down. Take D up, bring A down. Take C or B, bring B down. Look at it. If D goes up, A comes down. C goes up, B comes down. Is that not the matrix? Is that not the minor? You see that it's very, very simple. Minor of a matrix, if it's of a 2 by 2 matrix, it's very, very simple. Just interchange them. Just, let's say we're given 1, 3, 4 minus 2. And you're told to look for the minor of this matrix. What do you just do? This goes up, this comes down, right? Why this goes up, this comes down, right? So minus 2 will go up, 1 will come down, 4 will go up, 3 will come down, and you have done the minor. So that's how minor of a 2 matrix and 2 by 2 matrix is. Do you get? So it's very, very simple. So please don't forget. Now, so the next video, I'll be going to cofactor of a 2 by 2 matrix. How you solve the cofactor of a 2 by 2 matrix. But okay, or let me just explain it here. Now, let's go for cofactor. Cofactor of a 2 by 2 matrix. Now, how do you get cofactor of a 2 by 2 matrix? Before you can get the cofactor of a matrix, you have to first look for the minor. There are procedures to these things. I don't know if you get what I'm trying to say. Before you can get the cofactor of a matrix, either it is 2 by 2 or 3 by 3, you have to first look for the word minor. So if I'm giving a question like this, let's say I'm giving a question 1, 2, 3, 4. I was given a matrix like this, and they asked me to look for the cofactor. They just say, look for the cofactor of this matrix. Don't just be too rushed and go and look for it. You have to first look for the word minor. Because how do you get a cofactor of a 2 by 2 matrix? You get the cofactor by multiplying the what? The minor of that matrix with what? With plus minus. This is how you just do it. You multiply it with plus minus minus plus. We derive the cofactor of a 2 by 2 matrix. I'm saying it now. We derive the cofactor of a 2 by 2 matrix by multiplying the minor of that matrix with what? Plus minus minus plus. I didn't say, don't go and change your own. It is plus minus minus plus. This is for 2 by 2. There's the one for 3 by 3. Do you understand? So if you want to get the cofactor of a matrix, it is by multiplying the what? The minor of that matrix. Don't forget, it is the minor. So if they give me a matrix like this, and you know that cofactor is just by putting plus minus minus plus, and you just gonna put plus minus minus plus, you are wrong, because you have to first get the what? The minor of that matrix. After you now get the minor of that matrix, you now put your plus minus minus plus. Do you get? So meaning that, let's say, okay, this is, I've done the minor already. This is my minor. I was given a 2 by 2 matrix A, B, C, D. And you know the minor will be what? D, C, B, A. D, C, B, A. This is the minor. So how do I now get the cofactor? What we just do? I'll just put plus minus minus plus. You know I've gotten the minor already. So meaning that what will you just do here? You just do what? Let's say, okay, let our A minor, let's say our A minor is D, C, B, A. So what do you just do? You put plus, you put minus, you put minus, you put plus. So what will be the answer? Plus D. This is plus D. This is minus C. This is minus B. And this is plus A. So this is how you get the cofactor. Do you understand it now? So please be very, very careful. Be very, very what? Careful. When they ask you to look for the cofactor of a matrix, you don't just put plus minus minus plus. You have to first look for the what? Minor. You have to first look for the minor. After you get the minor, you now put plus minus minus plus. That's for 2 by 2 matrix. So let me say it again for the last time. Cofactor of a matrix is derived by multiplying the what? The minor of that matrix with what? With plus minus minus plus. Do you get what I'm trying to say now? Now, another one, let's go for transpose. Let's go for transpose of 2 by 2 matrix. Now, how do you get transpose of a 2 by 2 matrix? Now, transpose of a 2 by 2 matrix is just very, very simple. It's just by writing the row, by writing the elements, all the elements in the row to become column, and vice versa. Do you get what I'm trying to say? Transpose of a matrix in general now, either it is 2 by 2 or 3 by 3. It is by writing all the elements in the row to become column and all the elements in the column to become row. Do you get what I'm trying to say? You can write it down, jot it down. Transpose of a matrix is by writing all the elements in the row. All the elements in the row will become column, while all the elements in the column will become row. Do you get? So now, for example, For example, let's say we have a matrix A as A, B, C, D. Now, if I'm told to look for the transpose of that matrix, so whenever you see something like this, just know they're asking you to get the transpose, even if they don't say it in words. Let's say your exam is an objective question, shey you get, or a CBT question, and they just put this sign. They give you a matrix A, they now say find A raised to the power of T. Just know you are looking for the transpose. That is this symbol for what? Transpose of a matrix. Please don't forget to. So whenever you see, just know that you are looking for the word transpose of that matrix. Now, what do we say? The row will become column. Why the column will become what? The column will become row. Now, this is the row. This is the row. This is the column, right? Now, the row will become column. This row will become column. So that will be A, B. You see that the row have become column. So this will be C, D. Now, if you look at it, the row has become column, while the column has become row. Is that not? You look at it very well. This AC is the column. Has it not become row here? It has become row. This BD is the column. Has it not become row here? This AB is the row. Has it not become column here? This CD is the row. Has it not become column? So do you understand now? Do you get it now? So that is how you get transpose of a matrix, of any matrix. Now going to adjoint. Going to adjoint. Adjoint of a 2 by 2 matrix. Adjoint of a 2 by 2 matrix. Now, adjoint of a 2 by 2 matrix is simply the what? Is simply the transpose of the cofactor. Adjoint of a 2 by 2 matrix is equal to the what? Is equal to the transpose of that cofactor. Now, what am I trying to say? Mathematically, this is what we're trying to say. That is adjoint. Let's say we have a matrix A. Adjoint of a matrix A is simply the transpose of that cofactor. So meaning that, let's say we have the cofactor of that matrix is simply the transpose of that cofactor. I don't know if you get what I'm trying to say. Meaning that what? Before don't forget, before you can get cofactor, you have to first get the minor. Now, before you can get adjoint, you have to first get the what? You have to first get the minor and the cofactor. Then after you now get the minor and the cofactor, you now transpose it, and that's how you get adjoint. So for the last time again, adjoint of a matrix is equal to the what? Is equal to the transpose of the cofactor of that matrix. So meaning that before I can get my adjoint, if I'm told to look for the adjoint of any matrix, before I can get the adjoint, I have to first look for the minor. After I get the minor, I get the cofactor, and after I get the cofactor, I'll transpose it. After I transpose it, I've gotten my what? Adjoint. So meaning that what? Okay, let's say we have, don't forget, let's say we have a matrix A now. Let's say we have a matrix A as A, B, C, D. So meaning that we have to first get the minor, which is A minor, Abi. A minor will now be what? Don't forget, this goes up, Abi. D, C, B, A, right? So what do you now do again? You get the cofactor of that minor. Cofactor of A minor. And don't forget, how do you get cofactor of A minor? By putting plus minus minus plus on that minor, right? So here will be plus D minus C minus B A. By putting plus minus minus plus. This is the cofactor. Look at the cofactor. You say let A minor be what? D C B A. So this is the cofactor of that matrix now. D minus C minus B A. So what do we now do? For us to get the adjoint, we have to transpose that cofactor. Now when we transpose it, what do we have? So we are going to arrive at, so the transpose of the cofactor will now be what? Let's transpose this guy now. The column will become row, Abi. That will be D minus B, then minus C A. Now look at it. The row has become column. D minus C has become column. Minus BA has become column. D minus B has become row. Minus CA has become row. Do you get it now? So I've gotten the transpose of that cofactor. Definitely. So since you know that what? Adjoint of A is equals to the what? To the transpose of the cofactor, right? So definitely this is my adjoint. Definitely, therefore, adjoint of matrix A is definitely what? That's D minus B minus C A minus C A. So this is how you get adjoint. So don't forget that adjoint is simply the what? The transpose of the what? Of the cofactor. Do you understand everything we've done so far now? So if you don't understand, please reach out to me. Send me a direct message. I will always respond. Shey you understand? Send me a direct message. I will always respond. And please don't forget to like this video and share this video. So we are going to 3 by 3. We are going to 3 by 3. So we'll do on minor of what? 3 by 3, cofactor of 3 by 3, transpose of 3 by 3, and adjoint of 3 by 3. So with that, I think there's no how the question will come. You'll be able to what? You'll be able to solve questions on what? On matrices and determinant. So please don't forget to give us a follow and do well to like this video and share this video. Thank you.